Good morning, everyone. Today we will discuss the remaining part of function, that is recursion. Recursion is very important topic, and whenever you are going to program anything, so if you program using recursion, it will take a small space but more time depending on the complexity of function. So what is the recursion? Okay, suppose the function name is f1, and if we call this function inside this, okay, so this is known as recursion. Okay, the function will call inside this same function, so this is called recursion or recursive relation. Function that calls themselves like this can only solve a base case. So a function must have a base case. Okay, base case, there must be a base case, because without base case you won't be able to solve the recursive function. Divide a problem up into what it can do and what it cannot do. What it cannot do resembles original problem, and the function launches a new copy of itself, recursion step. Okay, so this function launches a new copy. Fine. So this recursion, suppose a function will call, suppose this is a function 1, and then function 1 will call again function 1. Then this function will again call function 1. So this is the step how function will call, and then this will return to this will call, this will return, and finally this will return to this function, and finally the outcome or output will come here. Eventually base case gets solved. So finally, actually this recursive function will not solve anything. It will solve the base case. On the basis of solution of base case, it will solve the remaining other functions. So it will call so many functions, and finally it start with base case. It always starts with solving a base case. Okay, so let us see, and get plugged in, work its way up and solve the whole problem. So this is one example of recursion. Here you can see the factorial 5 can be written as 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And just think it over, that how can we write? This is our 5 multiplied by 4 factorial, yes or no? And after that 5 multiplied by 4 multiplied by 3 factorial. After that 5 multiplied by 4 multiplied by 3 multiplied by 2 factorial. And then base case will be coming. What is the base case? So base case is if n equals to 0 or n equals to 1, it will return 1. So are you able to get me?
Yes, sir.
Is it clear to you?
Yes, sir.
Okay. So this is our base case, and this is n multiplied by n minus 1. Okay. So this factorial problem here, you can see that it is n multiplied by n minus 1. Each and every time you can see the same step, and that's why you can solve the factorial problem. It can compute factorial recursively and solve the base case 1 factorial equals to 0 factorial equals to 1. So here we have written that factorial of 0 and factorial of 1 is 1. And remaining other will be likewise. So when I want to write a factorial function, so suppose I am writing a function long factorial integer n. Now, what it will do? So initially it will solve for the base case. Yes. If the value of n equals to 0 or n equals to 1, here I am writing integer f. So f equals to 1. Okay. Else, what will be our result? What I need to return, that I must calculate, this must be n into factorial n minus 1. Okay. So where I need to store this variable n equals to n multiplied by factorial n minus 1. No, this is not correct way. Some other value I need to take. F is 1 for base case. So what value I can take? Suppose I had written here k. Suppose k is written and the initial value of k equals to 1. Then no, k equals to 1 will not work. K equals to n. Okay. Now this k equals to k multiplied by factorial k minus 1. And likewise, and finally it will return what value? But this is not working. Let us see. Let me show you the case. Fibonacci and okay, correct. N into factorial n minus 1. So this is much better step. So it will return n into factorial n minus 1. Okay. And finally, this will give you answers. So how do we solve this problem? We will see later in the next slide. Let me explain the concept of Fibonacci series. So this is our example of Fibonacci series. What is Fibonacci series? Fibonacci series, you have seen the movie Da Vinci Code. Yes or no?
Yes, sir.
Okay. So what is in Da Vinci Code? They have used Fibonacci series. So what is this Fibonacci series? It will start from base case. This is our base case. Okay. And then these numbers will generate the next number. So 0 plus 1 will give you 1. And after that 1 plus 1 will give you 2. And then 1 plus 2 will give you 3. And 2 plus 3 will give you 5. And 3 plus 5 will give you 8. And likewise, this number will generated from previous two number. So each number is the sum of previous two numbers. It can be solved recursively with this step Fibonacci n minus 1 plus Fibonacci n minus 2. So here we have used long Fibonacci n. Up to nth series we will start. So if the value of n equals to 0, yes, in previous problem also, yes, we have written n equals to 0 and n equals to 1. Then it will return n. So this I need to erase actually. So eraser will not work. So let me write. Yes. This will return actually n. No, return 1. It will not return n. Because if we return n,
Yes, sir. It's written one.
yes, correct. So this will return 1. Fine. Now come here and see, this is our base case. What is our base case? 0 and 1. If n equals to 0 or n equals to 1, it will return n. Else return Fibonacci n minus 1 plus n minus 2. So let us solve this step. Okay. So initially, suppose we have called, I am writing as f. Okay. F5. F5 will be called instead of writing Fibonacci because very long word I need to return, F5 will be called here. Now, what is the value of F5? Here, if we see this step, so it is not 0 and it is not 1. So it will start doing this. It will return what value? It will return Fibonacci of 4 and Fibonacci of 3. Okay. Now, if we see that it is also not equals to 0 or 1. So what it will call? It will call differently. It will call differently. So it will call F3 plus F2. Okay. It will call the function F3 and F2. Why F3 and F2? Because it is written n minus 1 and n minus 2. Now, this will call which function? F2
F2 plus F1.
F1. Okay. Now F1 will return what value?
N.
Yes. We can also call one more value. It will not directly because it is under factorial. So, but it will return directly 1. Yes or no? So it will directly return 1 because our definition says that. So it will return 1. So how do it reach to 0? Yes. It will reach to 0. So this will return 1. Fine. Now this 1 will be added to this function. This 1 will be added and this function is divided into F1 and F0. So it will return 0. It will return 1. Similarly, this function will broken into F2 and F1. This function will broken into F1 and F0. Okay. So this will return what? Again broken into F1 and F0. And likewise, this function will run. So when I am going to call this function, this will return 1 and 0. Okay. So this will return 1. Now this F2 will return 1 and 1 plus 1 will return 1 plus 1 will return 2 here. Okay. 1 plus 1 return 2 here and this will return 1. 2 plus 1 will return 3 here. Okay. 2 plus 1 will return 3 here and similarly here it will return what value? 1.
1.
Okay. And this will return 1. 1 plus 1 will return 2. Okay. Now 3 plus 2 will return 5. So the final answer is 5. Let us see 0, 1, 1, 2, 3. 0, 1, 1, 2, 3. And final addition of these 5 numbers are 1, 1, 2, 2, 2, 4, 4, 3. Actually, 7 is the answer. Is there any mistake? This is any mistake at calling. Let us one more diagram is there. F3, for F3 it is returning what value it will return. Once again we need to check, है ना? Because better to erase the whole diagram. Again, F5. F5 is broken down into addition of F4.
F4,
4 and 1.
F3.
And 3.
Yes or no? Then
Yes,
F4
sir.
is broken down into F3 and F2. And this is F2
F2 or F1.
F1. Okay. Now this will be F2 and F1. And this will be F1 and F0. And this will be F1 and F0. And this will return 1. Okay. Now this will again broken into F1 and F0. So this
Z0.
will return 1 and this will return 0. After that it will summing into 1. This one and this one will return 2. This one and this 0 will become 1. This one and this 0 will become 1. And this one is 1. 1 plus 1 is 2. Okay. This 2 plus 1 is 3. And 3 plus 2 is 5. So 5 is the answer. So what is the series? 0, 1, 1, 2, 3. Let us see what will be the answer, because I am also in dilemma. My according to me, it must be what, 8. Okay. No, it must be 5. Summation of series must be 5. So let us see what will be the execution sequence. So here I had entered 5. Fibonacci 5 is 5. Okay, fine. The answer is correct. Our answer is also correct. Actually, Fibonacci 5, what is the fifth number? 0, 1, 2, 3, 4, 5. What is the fifth number? What will be our fifth number? Yes,
3.
anyone? 5. 0, 1, 2, 3, 4, 5. Fifth number is 5. And this is our answer. So let us better do solve for F8. Okay. Then you will better understand. And see, each and every function is only waiting for what value it is. Each and every function will wait for base case. जब तक base case नहीं आएगा तब तक ये problem solve नहीं हो पाएगी. Clear? So let us solve for 8. If answer is 8, then our program is correct. So let me solve once again. Yes. F8. Now it is broken into
F7, F6.
F6. This will further broken into F6,
6, F5.
F5. Okay. And this will be F5, F4. Now this will be F5 and F4. And this will be F4 and F3. This will be F4 and F3, and this will be F3 and F2, F3, F2, F2, F1. Okay, then coming here, so this is F3 and F2. This is F2 and F1. This will be F2, F1. This will be F1, F0. Having a pen and paper, just try to do by their own. Okay.
Okay, sir.
बहुत बड़ी प्रॉब्लम हो जाएगी. So, are you able to solve it by your own, or I need to solve it?
Can solve it, sir, but it's little lengthy.
Yes, sir, we solve it.
Solve करना है इसको.
कर
Okay,
लेंगे सर.
कर लेंगे ना. और नहीं तो मेरे पास एक और वो तरीका है जिससे हम उसको बहुत अच्छे से सॉल्व कर सकते हैं. सो सॉल्व करके ये देखना है आपको कि 0, 1, 2, 3, 4, 5, 6. So what will be the answer for 8? 6th is your 8, 7th will be 13, and 8th will be
21.
21. 21, na?
Yes, sir.
So this will your answer. Let us see what will be the answer for 8. 8, there is no 8. For 10, 55. Okay, so Fibonacci 6 is 8. So you need to solve this according to you, and if it is not able, you are not able to solve, then please call me. Similarly, I had added one more program. Actually, this is combination of recursion plus what one can say iteration. What is the difference between recursion and iteration? Iteration ends at particular condition, like c equals to c is less than or equals to n. If this n will come, it will halt here. But recursion will halt. Recursion will work infinitely if base case is not provided. If this base case is not provided, then it will means what it will run infinitely. Okay, so we will see the infinite loop recursion also. Here Fibonacci is given integer n, enter the value of n, printf Fibonacci series, we have printing the series. So this loop will work from c equals to 1 to 5, suppose 5. Okay, 1, 2, 3, 4 and 5. Now what it will printing? Fibonacci I. So Fibonacci I, it will printing Fibonacci I, Fi. Fine. So what is the value of I? Here you can see that I is also iterated, and the value of initial value of I is 0. Okay. So Fibonacci I, Fibonacci 0, Fibonacci, yes. Fibonacci I, initially the value of I is 0. So Fibonacci, this loop will run from 1, and but Fibonacci I is 0. Now this will be plus plus. Okay, Now in the next loop, what it will happen? It will call 1. It will call 1. For c equals to 2, it will call 1. Then it will return 1. Okay. Now, if it is 3, then it will run for F2 and F1. Okay. Now, this will return value as 1. Fine. And this 2 will return value as 1 plus 0. So this whole thing will return 2. So here 2 will be, but how 2 will be answered? Your answer must be 0, na? In second term, let me solve. Yes. So c equals to 1, c equals to 2, c equals to 3. If I am putting 3 here, then what value it will be returning? Any guesses? This is your F3, and F3 will be broken down into F2 and F1. Okay. And then this again broken down into F1 and F0. So here the answer is not appearing correctly. Yes or no?
Yes.
This will return 1, 1, and this F1 will also return 1. So 1 plus 1 is 2. जबकि यहाँ क्या आना चाहिए?
1.
1 आना चाहिए.
1.
How? हम लोग एग्जीक्यूशन सही कर रहे हैं ना? फिबोनाची 3 is
हाँ सर.
नहीं, हम लोग गलत कर रहे हैं एग्जीक्यूशन. बहुत ज्यादा गलत कर रहे हैं. एक स्टेप मिस्टेक है हमारी, और वो स्टेप क्या है मैं बताता हूँ. हमने i की वैल्यू कहीं लिखी नहीं है. हमको i की वैल्यू लिखना चाहिए सबसे पहले. सो i की वैल्यू क्या है? इनिशियली 0 है, इसके बाद 1 हुई. In this loop it will be 2. Okay. Now F2 will be called and this will return 1. Yes or no? And for fourth loop,
Yes, sir.
this value will be 3. Now it will call F3 and the answer is 2.
2.
And this is 4, I equals to 4. So the next term is
3.
3. तो अब आप लोगों के पास यदि ऑब्जेक्टिव टाइप का क्वेश्चन आता है तब तो बड़ा प्रॉब्लम हो जाएगा. प्रॉब्लम ये हो जाएगा कि व्हाट विल बी द फिफ्थ टर्म. ओके. यदि मैं क्वेश्चन पेपर बनाऊंगा, सो मैं लिखूंगा व्हाट विल बी फिफ्थ टर्म starting from 0th term. Okay, so this is actually fourth term. This answer is actually fourth term. Correct?
Yes sir.
And be careful.
Yes, sir.
If I am writing first term, so this answer is correct. If I am writing 0th term, then what will be the next value? This will be your 5. So be careful. Okay. So what is the difference between recursion and iteration? So recursion will, repetition, both recursion, iteration, explicit loop means 1 to n. Let me show you. What is repetition? Repetition in case of iteration, the loop will work for 1 to n. This is one example. Recursion. If no base case, then run infinitely. An answer, I don't know whether it will display or not. Termination, iteration. जैसे ही आपने if means inside n is less than or equals to 2. But recursion, it is a must. When base case is there, then only. Both can have infinite loop. Yes, both can have infinite loop. If we define the loop, n is greater than or equals to 2, like this loop is infinite, okay? For I equals to 1, for I equals to 1, I is greater than or equals to 2, I plus plus. You can see that I will start from 1 and this condition is always true. Whenever I am increasing the number, I is greater than or equals to 2. So each and every number is greater than or equals to 2. And that's why this loop will run infinitely. Both can have infinite loop. Balance, choice between performance, that is iteration, and good software engineering. Okay, recursion is coming under good software engineering practice. So that's why you use the recursion. So let us see each and every example one by one. So our first program is factorial.
So your screen is not visible.
Yes. I am just copying the program from somewhere else. Okay. I'm not typing my program. So now this screen is visible to you.
Yes, sir.
This is our factorial program. So our base case is if n equals to 0, it will return 1. Otherwise, this will call factorial function because here don't like I don't like this find factorial and all. Okay. So now this is our function factorial, and this is also yes. Factorial equals to factorial number. So this is the calling function which will call the function and it will print the final value. Or you can simply write the you need not to go for fact. Okay, you can simply write this factorial here also. Both is having same value. What it will do, it will call the factorial function and it will start calling the function, and here base case is n equals to 0. Actually, if you put n equals to 1, then also it is very good practice because for 2 times it need not to go for somewhere, but no, not an issue. So this is your function. Let me copy this function. Here, Control M. This is our function, factorial function. So I am removing all these things, but you need to write the base case. This is our base case. So each and every function which will call itself, we need a base case. Okay. So what is there? If we call a function here, it is base case. Okay. Now suppose I am calling factorial of 5. What it will do? It will perform here. It is checking for this value. If this value is not there, then it will call two different strings. First string is 5 multiplied by sorry, eraser and multiplication I will put in between. Okay, 5 multiplied by factorial 4. Now, because this again, this is not a base case, so what it will call? It will call 4 multiplied by factorial 3. Now, this is not a base case. It will call 3 multiplied by factorial 2. This is also not a base case, and we are recursively going down to multiplied by factorial 1. Because each and every time, what is written here? N. So this is value of n. This is value of n. But until this value is available, we will not able to solve the problem. Now this factorial 1 will divided into 1 multiplied by this f0, and f0 will return 1. 1 multiplied by 1. Okay. Now it will start from, so see, recursion will start from base case. Okay. So it will always start from here. So this will return 1. 1 multiplied by 2 is 2. 2 multiplied by 3 is 6. 6 multiplied by 4 is 24. 24 multiplied by 5 is 120. Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes,
Ah.
sir.
So this answer is due to base case. This is not due to base case. This is the value of n. These all are value of what? Current value of n. So here fi is the calling function. Okay, f5 is the calling, and this will be the recursive function. This will be the recursive. This is calling. This is recursive. This is again recursive. This is again recursive, and so on. So you can see that ladder type of diagram will be generated. Fine. So अब आप factorial आसान से कर लेंगे.
Yes, sir.
Suppose एक नंबर दिया हुआ है 13579 11 and so on. तो आपको इसमें 5th नंबर पहचानना है, 6th नंबर पहचानना है, तो आप इसके लिए बना सकते हैं रिकर्शन. What is the base case? If n equals to 1, return 1. Else, what it will return? What it will return? So just try to solve it by mathematics. Okay. In maths, there is a book in class 12, and you can see that how do you solve this problem by recursion. So this is actually recursion of odd number. Fine. So let me show you recursion example of odd number, because I was not ready for that. Recursion of odd numbers. because we are interested in that particular term. Yes or no? Okay, all these programs are here for summation of series. So I'm not interested in summation. I'm interested in the recursive term. So just try to develop that recursive term and then we will see what will be your answer. Print even or odd number. This is one example, but I am searching for very simple examples so that you will be able to understand very easily. Otherwise, I need to solve it by mathematics. Okay, let us left this problem here and I will show you how this will work. Because factorial is very easy. Each and every time you need to multiply, but here you need to return and you need to return like the previous example of Fibonacci series. So it will be solvable by same Fibonacci series, but you need to solve the base case also. Any doubt till now? No doubt? Okay, so just try to solve recursive mathematics, okay?
Okay, sir.
I'm showing you recursion in mathematics. So here, okay, this is also given like induction and all, but not the whole recursion. Yes. Here it is giving you a solution. Fine. Basis, present main step. Like this is our example. And the last output is n square, 1 plus 3 plus 5 plus 7 up to n term. Prove that sum of first and odd number integer is n square. Okay. So here you can see different examples, but this is not truly, this is by induction only, and this is by recursion. Okay, so here you can see arithmetic progression factorial is also solved by recursion. So this is solved by recursion. Greatest common divisor factorial function base case is given and all other cases are also given. Okay, similarly other function, some other functions are also given. So I will collect all the example and in one day I will explain all these things. Fine. Because without any great example, there is no meaning of solving all these things. Any other doubt?
No, sir.
I think factorial and this Fibonacci is clear to you, but I want more example. Okay. So thank you very much. Have a nice day. Have a nice time.
Thank you, sir.
Thank you.
Thank you.